more people are
So it's my great pleasure to introduce Bob Frankston, who imagined a world with a spreadsheet before computers really had a useful thing to do, and so it was world changing. And I think what's really interesting is when I met with Bob a couple weeks ago and we started talking, we immediately got into a really strong agreement and a really good argument, all within about 4 minutes. And so I thought that's the kind of guy I want to talk here. So thanks for coming, Bob. I really appreciate it.
Okay. Yeah. Now, as some people here know, my history goes back well before VisiCalc, which is actually Dan's idea. But rather than go through, well, I will go through history, but let's start the talk. Spacebar, that's a good way to move forward. So I'm going to start at the end point. Both of the talks sort of give a sense, what the high-level issues are, and the sense that I'm interested in sort of the endpoints of connections, not all the network crap in the middle. Because the internet itself is just a technique. It's the way we can use whatever's available to communicate. The problem is that with all these people who think the internet is important, that's the thing in itself, that there is a thing called the internet, and they sort of have to defend it and make it work. And for me, it's just that stuff in the middle. I just start with sort of what you do with it. And you mentioned using VisiCalc. Some people have the Student Information Processing Board at MIT, which I co-founded in '69, trying to get people to use computers back then. I had a sense they were useful. Nobody believed me, but and this is actually the culture of Project Mac, which is in the building that's inside one of the Novartis buildings now, which is the attitude of how do we make this technology useful? What can we do with it? So I'm already skipping outside my talk, but for me the slides are mainly a guide. They try to keep me on track. And one point, there'll be lots of points we can discuss later, I'll just mention. One of the big insights is the least important thing we do is exchange content. Now that might sound heretical, but how many people have ever sent a copy of Wikipedia? You just say the word Wikipedia, you refer to it, you never send it. And that's part of the secret about what makes this work. Yet all our policies, all our measures of broadband and everything we're running out of internet are based on the idea we're shipping exabytes of data through this one router, which must be in the middle of Kansas City. But for me, the internet is really about opportunity. How do we create opportunity to do things at the, well, there's no real edge, but outside of the net. And the other important point is that the internet is a discontinuity. When you read the classic histories of the internet, they start with the ARPANET and have packet radio. No, that's nonsense. Yes, there are excellent technologies were there, but the internet really started from a very different beginning. It was the revolt against networking as a service. You didn't need a third party along the way to read your telegram like a scribe and repeat it down the line. You could just, you did it yourself, you just exchanged these meaningless bits. And one of the really horrendous legacies we're still stuck with is the idea that a carrier in the middle must make a profit for you to do anything. And I was reminded of this, I mean, I understand why companies need to make a profit. The question is whether that's the right model. For example, airlines, I don't have a better idea for airlines, but the consequence is I'm not going to be able to get to Las Vegas tomorrow because airlines no longer have enough extra equipment. So basically, they cancel my flight because gear was stuck somewhere, and there's absolutely no resilience. The whole system shuts down. And maybe airlines have to do it, but for us to use that technology for networking is absurd. So as I said, the internet is a technique for doing things ourselves. Now I put in DIO as a point because doing it ourselves doesn't mean you do it alone. It could be doing it ourselves. You have communities that work together, but it's easy to just think of doing DIY as opposed to depending on a third party. Do it yourself. So, and the other thing we get to is once meaning is outside the network. Oh, just realized you're not seeing my slides. Yes, there are slides here. I'm more coherent than I seem because the explanation was up on the slides. Speaking of depending on a third party and not having eyes in the back of my head, use video cable. Continue to use video cable. Oh, there it is. I won't go back to the other pictures nor show my beautiful picture of the trolley in the snow. Okay. That explains why you will actually look at me and seem to be awake. Okay. So you let's see. If I hit backspace, what happens? Oh, you go back to the previous slide. I can go back all the way back, but that's not important. So there's where you see DIY versus DIO. You wondered why I was. Okay. Do I seem more coherent now that you see it? Okay. So what does this mean? That this is really about taking advantage of opportunities. And we're limited by discovering what we can do. For example, voice over IP was a discovery. It was yes, we can get it to work in some cases in the early studies, but how can you do voice over a net? When you lose your packets, you got high jitter. Just like TV, people thought we needed isochronous TV, but some people were creative and figured out ways to take advantage of opportunities. Now, it's not always obvious. Like the only reason, well, not the only reason, but the reason VoIP works now has nothing to do with making VoIP work. It was the web that gave us the capacity. If we try to make VoIP work, we actually did. It's called SS7. And right now, does anybody want to buy a used phone network? It's too expensive to maintain. But the key is to have an appropriate business model so that, and this is one of the main messages, so we don't need a third party in the middle like the airlines do, have to limit to run at the edge to only do what's profitable. It's sort of like depending on the railroad to get to a destination. Not many railroads are willing to run tracks up Mount Everest. So we want to get away from this idea of the provider making profit for us to do anything. The other problem we have with the current business model is that providers' worst enemy, the people they fear the most, the existential threat are the customers. Whereas a customer buying from Netflix will remove all the profit of selling content, as the cable companies do now. And there's a slideshow I point to on my site from the cellular industry, explaining that abundance is the greatest threat. That if they don't prevent abundance, people are not going to buy the services. So if you wondered, why there's a problem with broadband crisis, it's obvious. The giving the customers enough capacity is a losing idea. So this is not sustainable. We need to have a sustainable business model, and this is, again, Google, since you use connectivity to encourage capacity. Now, but since, as I said, we exchange references, not content. Capacity is not the same as bandwidth. What capacity is being able to take it. Turns out we have so much capacity. We're using at the first approximation 0% of our capacity, and that's versus conflict of interest. So there is an alternative model, which is the way we find sidewalks. The sidewalk owner does not view the user as a competitive threat. But people talk about privatizing the Mass Pike. Then Route 30 becomes a competitive threat. You already saw this in Detroit. There's a private bridge in Detroit. They try to keep the city from building a public bridge because there's competition. So you've really got to be careful about what incentives we create. Now, what the resource I describe as ambient connectivity. And I use this term for the idea of wherever you are, you can just assume connectivity. Now, this is sort of like having open Wi-Fi everywhere, except I don't want to tie it to any particular technology. Current Wi-Fi is much better than it might be, but it's still, a problematic technology. But the key is to assume be able to assume we're connected wherever we are. I'll get more into this. I add the word permissionless because people somehow seem to assume you've got to, show your credentials, prove you can pay for it. But how many of you have to, show that you're authorized to use a sidewalk? That's the exception, not the rule. And the thing to realize is this whole idea of networking, we so implicitly have a provider-centric view. We talk about the network as what's important, how do you maintain the network. And as we'll see, a language, a framework is infused with a provider-centric view of protocols and everything. What you have to do is think, forget about the network. I want to be able to think just about the relationships between the two endpoints and what I'm trying to accomplish. It should just work everywhere, or I shouldn't have to log into this or connect to this. Yes?
One of the big struggles we've had is that users want to be able to define what they get from an ISP, and the ISP is usually unwilling to commit.
We shouldn't, yeah, and we shouldn't have the concept of an ISP. Because the internet is not a service that's being pumped out of the salt mines in Louisiana. It's what we do with the available resources. If the internet is a technique, then, you know, that's what I'm saying about flipping the model. People assume they have to ask the ISP. No, you're important. The ISP should come to you and say, please, I want a job. What can I do anything for you? And this is why, and again, I'm very interested in how language works. So I have to use language to be familiar with. So I say open access, even though words like that are so provider-centric. One of the big words we use, terrible words, is broadband. What is broadband?
Effectively a bigger pipe than the other.
Well, actually, it's a technical term that comes from radio technology. Turns out the companies that extended the TV antennas off the top of the mountain took the broadband over-the-air signals and put it on a coaxial cable versus baseband. And that became, as I'm going to give examples later, associated with the business model, because that's the way language works. And now, and then it became literally a contronym. And if you know, literally itself has become a contronym. A contronym is a word that's its own antonym. And the way language works, it literally fills in the same slot as figuratively, so people tend to confuse the two. So broadband, we used to mean the internet, when the internet is really what we tunnel through despite the broadband business model. This is what makes it so hard to talk about this. And I have to emphasize, I'm talking about an architecture, not any particular implementation. So when I talk about having open Wi-Fi, that's just an example. It's one way to do it. I don't want people saying, what amazed me, how often people say, oh, we'll give you a wireless mesh. First, when I say wireless, a wire is just a waveguide for signals. There's nothing wrong with wires. And mesh is just a particular technology. And if I've got a fiber which takes me across the country, why do I want a bucket brigade? It's an economic problem with solving. Technology is just a means. What we do have to do is preserve the magic of just works. And that's the real architectural goal. That's the power of architecture. Network just disappears. And apps can use any available means, including like QR codes. But if we're just exchanging a reference, I can just give you a QR code. So one way to explain this is our view of the history of what I call digital. Now, when I say digital, I mean discrete symbols. It doesn't mean 10 fingers, but the fact that we can have these sharp distinctions and you can regenerate the meaning. That's the real value. If there's zeros and ones, they can be regenerated. But it's also alphabets. If I write letters, we never really had pictographics. Hieroglyphics were very distinct symbols. A little off, you can guess what it is again. And that allowed the message to be preserved over distance. You can carry the message. If it got a little distorted, you can correct it, smudged, but also over time. And we actually had some forward error correcting in oral traditions, but that's for those when you want a discussion, details of language. But one of the legacies of the early days of inarticulate digital is with the telegraph, we had to use the wire to keep the signal contained, to maintain the relations between the bits, the endpoints. So I flooded our skies with all these wires. Every call needed its own wire. And you think that's bad? Even when we had wireless, no wires, we created virtual wires. This cockamamie idea of single frequency signaling creates scarcity. I mean, it's as if we said no two people in the room could wear a blue shirt because it'll be confused. Interference is not a property of physics. Waves pass through each other. Interference is another word for confusion. So whenever he talks about interference, they're just saying we created confusion. If you use all the rich data, and in a sense, if you look at meaning come from context, big data is fundamental. Information isolation is meaningless. Yet, our entire telecommunications system is trying to carefully preserve. This is the inarticulate digital. We have to carefully preserve all this stuff because, it's a great hack. By the way, the tuning fork was a wonderful discovery back then. The fact that it's been used to compromise the Constitution and prevent free speech, well, collateral damage. The other reminder is that business models, again, like broadband, the business model came from the accidental properties, of history. The single frequency, single hop signal gave us a business model of radio. And if I make it to CES this year, and I ask about radio, I found radio, Pandora is radio. Tubes and transistors are no longer radio. Beware the language. Okay, so the talking telegraph really created havoc because we had this great technology, digital, can cover any distance. And then this guy across the river there disobeyed his father-in-law, stole an idea from Elisha Gray, who retired to West Newton, and created a talking telegraph using analog technology and made a mess of things. Distance now became difficult. Distance used to be easy. Telegraph would go over any distance. Distance became hard. And, without explicit understanding, we could tune things, we could tune knobs and all this stuff, but it was very hard to preserve a signal, across the street, let alone across the country. So this guy, Claude Shannon, did a lot of research on, created this whole technology for how to preserve a signal within a wire, within a channel. He didn't use the term wire, he used a channel. It wasn't a very abstract term. He called it information for the same reason that physicists, as you point out, like to use words like work. Or we had giant brains, all this notation, anthropomorphic notation. We use the word communicate, as if these wires carried a meaning. And we're still living in that legacy. Matter of fact, here, it's more than a century after that picture I showed you of the wires covering all the streets. Yet, it's even worse. All we've done in a century and a half is learn how to take all those wires and bundle them up very neatly into little tiny packages. And worse, we have multiple bundles of wires from competing bundlers, or bunglers, whatever you want to call them. And it's even worse. Inside each of those, we have virtual circuits to maintain each conversation. Now, how you can maintain a business model of carrying bits where there's no longer any way to compete. In other words, they're just bits, they're generic bits. How do you differentiate? But the reason we have the legacy is we're still stuck in stage 2. The idea that you need pipes, 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 and it comes out in many ways. One is carriers don't want to become dumb pipes. Sorry. That's not the worst of it. It's the fact we don't need pipes anymore. The bits are all self-identified meanings assembled outside the network. We don't need pipes. Yet our business models are still pipe-based. Now, the digital technology that gave us computers did set the stage for the future. But we first have to, again, this is why I brought up the issue of language. How many people think physicists should run the NLRB, National Labor Relations Board, because they understand what work is? Why would a double E be allowed to run the School of Communications and the PR department? Those people understand communications. Apparently E's don't, because they confuse information in the Shannon sense. I mean, how much information is there in not answering a question? I'm going to pause. There are people who spend a lot of time figuring that, and you have to slap and say, no, that's a stupid question. Okay, now this sets the stage for what I'm calling stage 3. Now, very interesting development. I took a class in spring of 1973 from Mike Hammer. Does anybody remember Mike Hammer? Re-engineering. We were studying networks, and one of the things we studied was AlohaNet. How many people here know about AlohaNet? Okay, it was a radio packet network in Hawaii, a do-it-yourself packet network. There have been various experiments in radio packet networks, but I remember Aloha was the one we studied in class. And basically, it was, what any hacker would do. You lose a packet, resend it. I mean, no big deal. Maybe if it's the latest temperature, you don't resend it. You just give the new temperature. I mean, we called it a net. It was called AlohaNet. But it was not. But it was a network in the sense Facebook is a network, or sorry, Google Plus is a network. It's a social network. It's not. That's the problem with language. Again, this is why I'm so fascinated by language. The word network is so general as to be totally useless for communicating. Worse than useless. It's sort of like diplomacy. You can both use the same word but mean entirely different things, but think you're talking to each other. And at the end of the class, I remember the kid sitting next to me, this is May 1973, did his baseband project. He took Aloha and put on a coax. Now, I wanted to do it over the campus network. It would have been broadband, but I didn't follow through, so it doesn't count. But it was obvious this is a great hack. 2.995 or 994 megabits, if he reminds me. That's Bob Metcalf, you know. It was wonderful, but to get his doctorate, he had to prove to the EE people that it would perform well. Turns out he was wrong. It performed much better than his thesis said. So, how many are familiar with the paradigms, framings? When you change a paradigm, everything changes. So when Copernicus did this little thing of moving a reference point 93 million miles, it was a nice mathematical hack, and it did make navigation easier, but it had two side effects which you wouldn't have anticipated. One, it destroyed people's idea that they were in the middle of the universe. And that made it very hard to accept. And I'm telling you, meaning is not fundamental if you want a scary concept. The other thing it did was give Newton his physics, because suddenly you could see a uniformity out of all these disparate things, and you just get a deeper understanding. And in that sense, what the packet radios forced us to do was learn how to preserve meaning outside of the network, discover what we can do with the opportunities. And that, I argue, is the real origin of the Internet. Learning how to solve problems ourselves, learning the techniques for using any available resource as a way to communicate in the human sense, not just in the EE sense. And that's why I see a fundamental discontinuity, yet we're still thinking stage 2 because we, as I said, language, information, communications, it just sounds just like the railroads of the 19th century. And in fact, we have a thing called the Federal Communications Commission. What does the word communications, do they mean by communications? What's worse is they're explicitly spun off from the ICC, Interstate Commerce Commission, which managed railroads. Now that's gone. It's been replaced by Department of Transportation, which manages the means we use to travel. It does not manage the actual freight itself. In the meantime, the FCC is there telling us what words we're allowed to use, how we're allowed to run elections. Really weird. You think these people didn't understand how to communicate. And we're still compromising the First Amendment by creating scarcity in order to keep the business alive. So the Internet happened when we interconnected the LAN. So the LAN, you plugged into anyway plugged the coax, you were just there. But the consequence of that was you could not see beyond the individual packet. So therefore, we had to have a system, and this is the real insight, to separate TCP from IP. And it wasn't just, Vince or Bob Kahn. There were a number of others working on David Reed locally, and Dave Clark and all these other people. Was how do you allow, preserve an application relationship independent, when you could just exchange nothing above packets. And this is where the end-to-end argument. You had to solve have meaning outside the application. Okay, I skipped over. Well, since I mentioned early slides had TCP mentioned explicitly. What TCP is, it says Transmission Control Protocol. Very interesting. Because if all you want to do was preserve, make sure all the bits got through, you keep retrying until it gets through. But TCP was also a protocol for cooperatively sharing the resources in the middle by detecting congestion, by backing off. And what's amazing is how well that worked. That it's really a social protocol for sharing resources. It's not just a reliable stream protocol. And basically, yes, you can violate it, but if more than a few people violate it, collapse, you get immediate feedback. People use standard libraries. So it's a whole interesting discussion about why that works, and sociologists, should study this some more. And I won't go into problems like buffer bloat. There's lots of other issues. But what we needed, so where I come into this, and this is much more prouder than doing VisiCalc, was home networks. Home network, the original triple play plan, or N-tuple play, like Sprint Iron is a good example. They would haul a pipe into your house. They would put an ATM card cage in the basement. ATM was asynchronous transfer mode, the base for DSL. I'll try to avoid too much acronym soup. By the way, ADSL is interesting. You know why DSL exists? For interactive TV. It was not created for the internet. That was a later repurposing. There's a lot of repurposing discovery. Hindsight history makes things look so purposeful. People have a reason for everything. But if you remember that beginning when you had to run a separate wire for each relationship, well, those wires, virtual wires, were inside an ion, a pipe, or any of the other triple plays. Each phone line was delivered to the card cage, and in the early days, remember, the phone companies owned your phone. The service was the conversation. It was not the wires coming into your house. And therefore, in the 1950s, AT&T had to be sued to allow you to put a box around a phone, because there came a device called the Hushaphone, compromised the quality of the service and besmirched the reputation. Later, the Carterphone allowed you the equipment on, but the Hushaphone, I think, was a more interesting case where the boundary of the service is. So. And you can see the example of how that works in practice. Carriers would want to charge for each IP address as if it were a phone number. You're going to pay for each IP address. Since they looked inside your house, they can do things like trying to ban webcams, but those are an abuse of the service. Familiar with the site at home? That was repurposing a video distribution service for internet connectivity. And today, the modern version, that's called Google Fiber. And Google Fiber's attitude is you can't share. They're telling you what you can do with the bits. Now, what company would be so evil?
Are you referring to the no servers allowed?
It's not just, no, that's the least of it.
That isn't.
No, I understand. Verizon had the same attitude. And the nice thing about terms of service, well, I'll be nice to the FCC, so I won't say fuck them. But back when I was doing home networking, and I'll get into that, I basically ignored the terms of service because the phone company said you are not allowed to hook more than one PC to your home network, to the router. They're going to tell you what you can do with the devices inside your own home.
So for the Google Fiber no sharing, you mean you can't?
So
community over
yes, no, it's not just watch TV. If I have a Google Fiber coming to apartment house, I'm not allowed to share that connection with my neighbor. Now, I'm going to have the business model point of view, which is why you need a business model that doesn't create such terrible behavior. But there are people who try to bring, like, housing communities. You want to bring broadband to the poor. You got a gigabit. That'll serve complete apartment houses. Steve Ronan here uses just a few megabits to serve the Ruggles project. So that's, it's as if you, yes?
Yes, it's gigabit. It's not a 1 gigabit.
No, it's not. You play the odds, sure. But let people discover what it does.
Provider to tell you up front, yes, you may have 1 gigabit of bandwidth, but you only have a 5% net as a result. Apparently, this is going to result in degradation.
Yeah, let the people decide to discover that, sure. But what it's sort of like a sidewalk. We're going to limit how many people can live in the house. Yeah, I mean, this is where you'd have to the idea of discovering what you can do from the edge. Not sort of. I don't want guarantees. The reason Skype can do video is because Skype does not promise to do video. If they promise video, they could not do video. There are a lot of counterintuitive aspects here, which is why I have to start thinking from the resource and from outside. And you also have some interesting things, like if you're above a threshold, you got 10 people with sort of 10 connections, you get 100 times the capacity. But basically, like if you have a lot of DSL wires to share them, you get disproportionate improvements. Like one lane highway will get more traffic jams, more than 3 times the traffic jams of a 3-lane highway, because you start to use the resource effectively to fill in the holes, you accept delays, and it all depends on the application. If we're just extending the word Wikipedia, who cares? A gigabit is wonderful. Even if you got a 10 megabit, let me share it, let me decide. But it affects the business model. That's why I keep coming back to the funding model. I'm not saying it should be given away. We need funding models that work with sort of societal needs. Yes.
Well, one big sticky thing here still is legal issues, including intellectual property enforcement.
No, but that's not in the wire. The bits are bits. They have no inherent meaning. This is a homeopathic theory of communications, that bits have a memory of their original intent.
We share a network connection at the multi-family home I own here, and one person who was visiting downloaded.
Yes, no, and this is why lawyers are one of the greatest threats to society. Basically, you should move the trial to Salem, which is the appropriate venue for such theories.
My point is, we do need, as a society, to come.
No, we have to come to the 20th century, let alone the 21st.
But isn't the fundamental problem referring to the fact that you're trying to share a resource that has huge level of contention?
Okay, the short again. Let me get through this. I'll get through this. The short answer is we're using 0% of the available capacity. So before you start telling me about a shortage, tell me where that shortage is. When I've got 3 broadbands come through my backyard and 1% of any one of them is my full internet connection, I've already got 100,000 times the capacity. So what do you mean? What do you tell me shortage? Where's the shortage? When the police will run a fiber to their gun detection sound thing, which only a few kilobits you need for gunshot, but deny anybody the ability to share that. People now run fibers to fire alarms and things. There are terabits of capacity going unused. So before we run about scarcity, show me there's a problem. And the other example I won't get into is meter reading. Now, meter bits are special. They can't go over the real internet. They need their own network so that phone companies can go back to AAA and connect a bill of money for each meter read. And if you read the IEEE numbers about how many gigabits of capacity and everything they need to read the meter, I mean, they need a whole fiber infrastructure, gigabits of capacity. Though if you run the numbers, you'll find out it's less than a bit per second. But you need fiber. We're really beholden to all these myths. So we need to start from the edge. And the other important point is local connectivity is more important than distant connectivity. We became fixated on long distance. Anybody old enough to remember when long distance would put fear in your heart so you can go bankrupt on a long distance call? That's because of that stupid thing with analog telephony that Al Bell did. With digital, it's no longer an issue. Anyway, more important, the people we know and stuff are nearby. I was reminded of this, was so hung up on social media, the network. My son last night was caught, foolishly decided to take a long drive to Phoenix. And he was going to go from Indianapolis, or he's going from Indianapolis to St. Louis. Turns out that outside Terre Haute, traffic was stopped for 12 hours in the middle of the snow. Online, social media, no information. If he had CB radio with him, and they almost took one, He could have found out from the truckers and everybody what was happening locally. And so, you can get across the country easily to get to a website, but you can't send a message from your light switch to the light fixture because that's still using this technology Ben Franklin understood. We forget, we have TV controls. You have to be on. There are so many problems with you have to be on the right LAN. You got to point the IR at the right device. We do all this work to a distance, yet we don't realize it starts locally, and then interconnecting these local islands is how the internet happened. And that's the important lesson I built on. So actually, I'm going to finish. So what I did with home networking is I made it opaque. By putting I was at Microsoft at the time. I put the NAT, and basically I prototyped it in my house. I did it for myself, and I try to do things that generalize. Like when Dan Bricklin did a spreadsheet so he could do his homework, we just did a general version of it. So the NAT was a nice hack. So people couldn't peek inside your house. They couldn't enforce the terms of service. You could share all you want. And occasionally they'll try to tell you, and the problem is, yes, some people look at the IP address and all sorts of, bad ideas, accuse you of being a witch because your bits don't look right. But the key is to make it just easy and give people the tools to use the resources available. How many people worry about, how many gigabits of video they're showing within the home? There's no cost. Suddenly it becomes expensive once you get outside the home. So the benefits of the ownership is you have as many IP devices as you want. There's no scarcity of IP addresses, no meter running. And right now we can run gigabits in the home. Remember, it used to be 10 megabits. It was very expensive. Modems used to be $300 for kilobits. But we're not quite there. We still have these perimeter security, these complex rules. Instead of abstracting security, making the application, we still think it's a property of the network. And these are all long discussions in their own right. And we still understand generic bits. We have USB, we have SATA, we have FireWire, we have HDMI. All these special packets as if they're also special and different. I didn't list DisplayPort here because that's really an application protocol which we should be pushing, but instead we're stuck with HDMI, which is equivalent to the old digital telephone, sort of faux analog, faux digital. So with home control we can learn by doing. But what people still think it's special because it's within a home, it's behind a NAT. When it's really just the example of, a do-it-yourself environment. Now, we have discovered, for example, want to solve a problem connecting devices. We just, one thing from the edge is we now, V6 is a dead issue at this point. Instead, we use V4 reflected to the cloud, which I think is a terrible idea, but it works. It's an example of you go with what works. But I won't dwell on that either, another topic. But we still use wires to define relationships. So how do we move beyond the home? The answer is very simple. We do what we did with the original internet. We basically interconnect the islands. We already tunnel between the islands. When you get a quote broadband connection, you're really tunneling out of your home through telecom. They own the other end of the tunnel, but that's a temporary historic accident. Won't go into why it happened. But we can take the same ownership perimeter and expand it out from your home. So if you and your neighbors share, which some people are already doing, an apartment house, you can get many benefits. You get two major benefits. One is cost savings. You share the capacity. But the other thing is you can get permissionless ambient connectivity. You can now do all those IP-based devices. You can buy some now, but the problem with perimeter security makes them very brittle and fragile.
It depends on what the perimeter is. In our building, we run our own services.
Yeah, but you still have to set. But why? But do you have a WEP or authentication?
I don't. It's been years since I was using any of those services.
No, but the answer is.
Server, you could tunnel.
Right, but you have that. But what you want to do is at least be able to have devices that just connect. I'm glad to see Google does not have an agree screen. But the problem is, you get things like this at JetBlue. Now, can somebody explain why? First, I have to call my lawyer before I can call my lawyer. I mean, there's something wrong there. I'm already at the airline terminal. I've already agreed to much worse things they can do to me, yet they have me type agree. This is something everybody should do what they can to get rid of those. And again, the fear. If you ask people fear, they'll say child pornography. That's just because they don't have any better idea. It's just they've learned this mantra. But if we paid for infrastructure like we do roads and sidewalks, we wouldn't have a need to shut things down just for revenue.
We accept, especially in neighborhoods like where my house is, that there are thieves, drug dealers, all sorts of criminals using those public rights of way to get by with no record that they passed. Because
you mean you let people walk by your house
yeah,
without signing an agreement and without paying you?
So, yeah, well, the paying is a totally different issue. We have
Well, ask Rand Paul. He demand pay.
We have a very different expectation of how freely usable for potentially illegal activities a sidewalk is compared to
yeah. Well, and this is what's amazing. I mean, we were really lucky by accident. In the Constitution days, that people were really pissed off at the king, so they wrote the free speech thing in. But every opportunity since, the fear is so, it's spelled NSA. And yes, it's amazing how people fear what they don't understand yet, which means you're not going to get any discontinuities, you're not going to get any surprises. But yes. But an important part of the whole lecture, why the First Amendment works, why things work despite the fact that crossing a street is too dangerous to do. So if we fund the infrastructure, again, this keeps saying, as we do sidewalks, these problems go. The reason for putting up a wall, this putting the fear aside, financial reasons goes away. Because it's so cheap, you pay for it once, like a whole network, and then you create opportunity to discover what we can do. We haven't even started to explore what we can do, because we can do high value applications, like in home control. No, I'm going to go to my slides, but home control is a wonderful example because we just start to discover what we can do with connectivity. But one of the lessons I learned with home control is that we can do high-value applications. We call them trophy homes. In other words, lighting scenarios, all these complicated high-value stories, TVs coming down, the shades, all this stuff, but we can't do light switches. Okay? That's the problem here. Without permissionless ambient connectivity, simple things become hard. It's not just permissionless. The DNS, the current, you must ask ICANN for permission. There are lots of other problems, but if we solve the financial problems, we then have an incentive to solve problems. We introduce resilience to the edge. You connect a wrong access point, you're walking down the street. You've got, Comcast and all these others connected to, and then Google Maps stops working because one access point got stuck. Authentication changed. Somebody broke it. The protocols at the edge aren't resilient. So there's a lot of work to do better protocols and have resilience in the whole network. Not meshing necessarily, that's just technology, but resilience. So the old model, we assume value is created inside the network. We have, thus we can fund the network out of the revenue, and that's where the cable TV companies are. They own the pipes, they sell resources, just like railroads sold rights. If you go to Netflix, that collapses, which creates the conflict. Fortunately, there's a new business model, which is the one I keep saying, just pay for the wires. They're so cheap, you put them in once. It's amazing how inexpensive. And, if we didn't put the fiber in, we would have been doing gigabits over copper. DSL was running megabits 25 years ago. Now, it's copper, I said, not pairs. You don't follow the DSL rules. You'd be very innovative. You do the bundle as a whole. And, at this point, if you simply, one way to use copper is to sell it as copper and buy fiber. I don't care. I'm just saying the economics is what drives Moore's Law. And then we won't have the need to exclude people for no reason other than forcing people to pay. Imagine sidewalks with a paywall around them. So, and to show you the value of this, let's look at a case study. Philips Lifeline is one of the local companies. They're now in Framingham. They were started locally. And initially, they would just have the radio from the device going to a phone and it would dial up. It worked well enough for the purpose. Hopefully the phone line was not in use and all the other things, but they put it before, and you can get it to work enough times to be useful. Now people are going to the next stage, which they carefully set up connection to the cell phone. If you set the Bluetooth right and use the right phone and you've paid your bill and the battery works and you're in the it can work. But the problem without permissionless ambient connectivity is the default is failure. Shouldn't the default be to just work? And that's really what I'm getting to. The idea that we want just works connectivity. Now, there are no guarantees, and this is why the VoIP story is important, because we can get voice to work. It turns out Skype works much better over lines that the traditional phone companies can't use, because their protocols are all brittlely dependent upon the network doing everything right, preserving a path. Turns out cleverness can make up for a lot. So this is why it's so important to have the incentives and create opportunities. And then there's a whole discussion, which I won't get into, is then we can start rethinking the current internet. For example, the post office understands routing far better than any of the internet people. But it doesn't try to send mail to you. It sends mail to a place. That's its job. You tell your friends where you are. So I can go through if anybody wants to. The other big topic we could do is where are the smarts. Smarts are valuable, so people want to own the smarts. But if you go into a restaurant, you want your wait person knowing what you're going to eat. You'd like to have some say in the matter. So, so I won't go into the challenges, but obviously there's a telecom industry which exists, and who rightfully sees this as a deadly threat. We have an FCC which is trying to transition to IP as if they're a desperate attempt to keep us in stage 2. By simply saying IP is the new phone wire, but everything else is the same. You don't transition. You let the whole thing fade into the sunset. At some point, nobody's going to care about it. You resell the facilities. And what does one do with lead-acid batteries? How do you decommission them? There might be a lot of money. If somebody can find a good use for lead-acid batteries, you make a lot of money. What?
Recycle them, I thought.
As what? Maybe they do, but I'm just saying, And the whole Internet of Things is just in the infancy. Well, everything I read about it is very special hacks. There's no general connectivity. But that, again, these are long discussions. I just wanted to introduce these as ideas at this point. And I can also, if I want, go to the other slide, which I'm proud of, is how to run out of the Internet when it's just a technique. It was like after hacking at night here, went to Union Square for French toast. And I was told, we're out of French toast. We asked you had bread, milk. Turns out the guy didn't know how to make it. And that's really what those wires are, is running out of internet. So, any questions? Anybody confused? Anybody awake?
So what happens in your do-it-yourself home small community network when it breaks?
What happens when your water pipe breaks?
You have service.
Yeah, so we'll have the new plumbers, and in fact, I'm actively trying to find people who want to start. In other words, the point I'm making is I'm actually in favor of business capitalists and all this. It's just you've got to have rational businesses, and the model changes. The original railroad. If you want to read a book, Railroaded, by Richard White, it's a wonderful story because it tells how the railroads in the West, this is opposed to ones in the East, which have different densities, were never financially viable. That's why we got the FCC, or subways in New York were never viable. So we had to have each infrastructure. So you have to look at how the incentives work, what's the business model, instead of just continuing forward. So yes, if we're viewing a time materials model as a business, we need plumbers because they're a time material business. Your plumber does not charge you for the cost of water at the price of whiskey. When you buy flour, you don't pay for it as cake. So you have to understand where the value is added. Question back there? The first step, one thing to do, and people are already doing it, is, first step is education. an understanding. But if you're an apartment house, get your friends and neighbors to basically make that a connected zone. Because petitioning the city is hard because there's too much education, the language, everything makes it very hard. How can you even talk about the FCC when their very definition is they were created to keep a business model alive. They're not technology. They were designed to, in part of a deal with AT&T, to make AT&T viable as the stewards of our ability to communicate. Things have sort of gotten out of whack, and they also got a right to do it based on spectrum allocation. But you understand how hard it is to get people to think differently. But if you change economics, if you're building, and there are a million buildings, so if you start to get your building to be a connected zone and work out from there, repeating the history of the internet, you start to get to an alternative which is viable. And I think that's the starting point.
You start to get, having been involved in small building connectivity zone efforts over a couple of decades, problems you have is still, as far as I know, too much expertise.
Yeah, if you want a problem, it's really bad in California, the Bay Area. Too many people who understand too much. That's why Palo Alto put in fiber, ripped out fiber. So yes, it's a matter of venue shopping and set examples.
But more, plumbing isn't a simple thing.
Yes.
But plumbing was simplified so that it could become a trade. And by having it established as a trade, regular people can become people who maintain plumbing. You need that for networks.
Well, actually, remember, I did that already for home networks. Your home network, when I first started doing home network in '95, think of the reaction I got when I said people are going to maintain their own home networks. So I did a couple of things. First thing, remember, I had this position of having been in class when we were doing this stuff. So I knew there was nothing hard there, nothing secret. I just had to remove all the things that made it hard, like configuring IP addresses and things like that. I've learned a lot since. There's a lot of ways that can make it even simpler. So yes, part of it is, this is why I talk about the current internet routing I compare with crossing a river by jumping on icebergs. Turns out we have bridges. Just use the bridges. It's like the post office delivers to addresses. So insights like that make these much simpler. All hubs and routers should be self-diagnosing. But until we have a market incentive to do this, it's going to be hard to make that happen. Unfortunately, I was at Microsoft. I was able to keep them, and I purposely made sure they had no way to monetize it, to control it. But they did get value out of connectivity, just like Google has a value out of connectivity. The more people can connect, even if they don't get even if 99% of the traffic is local, you can still start to offer all these new services and these new innovations. But I am actively looking for people to work with who do want to do business, and in both educating people how to do it themselves and providing the appropriate expertise. So yes, I don't expect most people to want to do their own networking or build their own networks, but there's no reason that it has to be hard. We're just used to it, the same as DNS. And we have this whole legacy because so much of today's internet goes back to the mainframe days, port numbers, all these issues, which are just legacies. And it's time we've learned a lot in the last, since we first did the current internet. Yes.
So this might be a similar idea. We just have to make it easier. But you mentioned problems being firewalls and such.
Yes.
One of the observed benefits of NAS is, I think at one time you put a Windows computer on the public internet and compromised in like 10 minutes, like definitely less than the patches.
Yes, and when I first did it, what I was saying is, okay, v4 closed the ports by default, but IPv6, we're going to be IPv6 IPsec. We wouldn't be stupid. We designed it to be aware. Now it turns out we're still stupid, but that's another issue. But yes, but we can't depend on perimeter security. So now, anybody, the Maginot Line in France, now, and you know how well it worked for them. Now it turns out Andre Maginot actually was not stupid. He knew you still needed an army, but he made a mistake. He died. And the politicians then said, "Army? We don't need no army. We got a wall." So people are building in hyper things. But look at Google's problem. Chromecast is on the wrong network. The device doesn't work. You know, so the answer is yes. We have to first have a better security model, because when you go to Starbucks, that same machine gets connected. That's based at the application level. The software level doesn't depend on the firewall. And in my model, if you have permissionless security, you're still going to have legacy stuff protected. So I'm not saying we get rid of all that. I'm looking at new opportunities.
One of the big incentives to have an apartment network, basically, small community network, when I was having a college-ish lifestyle, was that we could have our server serving the copies of our CDs to us the way we wanted. But now that isn't done anymore from the community, it's done centrally. Do you see obvious ways that Google could enable that sort of community hub when we're otherwise serving?
Well, I mean, it's interesting. One of the things that Western Digital is selling is a personal cloud, which is basically a disk in your house as a server, Pogo plug. A lot of people doing it, so I can easily see products, because, if you want to watch, multi-screen 3D ultra high definition video, you might want to. It'd be nice to cache on a server right in the building. It's physical. In other words, the physical. It's interesting. There's a sort of maraschino cherry problem. Maraschino is that you take a cherry, take all the cherryness out of it, then add it back. And in a sense, we've done such a good job of conquering distance, we have to put locality back in. But, Akamai, but that's pragmatic. I mean, there are two reasons localities. One is performance, and fine, put a caching server there. You can put that in a box. You can put, Chrome PCs should be able to work with local cache as well as remote. By the way, a little footnote, be careful about the word cache, but sometimes you explicitly put it there. You want to make sure, this information is there in case you get disconnected versus just for performance. You got multiple issues. So you can easily have protocols that allow peer sharing locally. This is sort of content-centric networking. So lots of reasons for doing it, but you also want, your thermostat and other devices to work within your house, when your connection further out goes down. So we have to understand that the relationships are separate from the, geographic. So there are reasons having geographic proximity. Sometimes I want a light switch to say, turn on the light in this room. And you might use techniques like IR, not for the message, not for turn the message, just so you know what room you're in. So there's still, again, I'm not saying, that's what I'm saying, we have to rethink a lot of what the internet is as opportunity. And the distance stuff, yeah, it's nice, but we forgot, there's a physical world there. CB radios, we need to do virtual CB radios. So if I'm, my son, next time my son is stuck on I-70 outside of Terre Haute, the truckers and stuff have a local social network, not just CB radios. Though they probably are nice that nobody else has CB radios anymore, annoying them.
You made a comment at the beginning about something like most information isn't involved in sharing.
Well, you mean we don't exchange content, we exchange references. Is that what you're saying?
I don't know. I was trying to.
Where I say Wikipedia instead of giving you a copy of Wikipedia? Yes. And we have to expand on that. I mean, that's a very interesting topic, because I used to give my talks and ask people, how much can we compress the Encyclopedia Britannica? And I would say to an ISBN number. And then it was, if you're communication theorist, you want to fit it into the old model, you say, well, that's it, the ISBN is a dictionary, just like any of the other coding we use is a dictionary. But remember, in communication theory, you have out-of-band signaling. You have an out-of-band clock, which enables a 3 kilohertz line to carry more than 3 kilohertz because of precise timing. But then he decided that's nonsense. It's too hard. It's really that we're just making references to things. So, and really, that's what language is. You send URLs. Now, URLs put aside URL problems. And then, so your effective capacity is meaningless. I mean, this is why clocking the number of bits of value is bad enough. It's already inverse. I mean, the longer the movie, the less valuable each bit is. But you can't even measure. Same movie can be a terabit, or it can be 10 bits, depending on whether you just need a reference or you need a copy. And I once sent a toy. My mother wanted to send a toy to a grandson, of course, in Seattle from New York. I said, fine, I'll have it there in an hour. I returned to Radio Shack, gave my brother the number, and he bought one.
The big usage, bits used driver has been people watching movies and such.
It actually turns out that's not that big. That's what Akamai is about. They're cached locally. There are two ways it's not a big thing. Number one, it's cached locally. Number two is Netflix does the compression that the original DS people only envy. So at 2 megabits, they can give you a high definition experience. Because you don't really care action on picture. You want to enjoy the movie. You know, they could, I mean, a cute idea would be to put a camera on, and if you're enough feet away from the TV, they'll de-res it, because you're not going to see the extra resolution. When you come closer, you can be, the point is there are no rules here.
But my point about that is that is a lot of what people consume from an ISP that the ISP.
Well, consume is an interesting word, but we'll put that aside, yes.
A lot of how they are sending bits or receiving bits. What we found with the service I work on is that if you call something caching rather than keeping a copy, then the content owners are much more willing to allow you to have a copy on the client side.
Oh, yes.
And therefore, community networks that merely cache the video in ways that the
yes, our language, our legal system is still in the 13th century. You try to, instead of science, which tests ideas, legal system proves things by examples. And that's, yes, not that I have anything against lawyers, but I have something against lawyers. Okay.